The first part of the fundamental theorem of calculus says the following. If f is a continuous function on some interval ab, then the function big F, which is defined by varying the upper limit of this definite integral, is continuous and differentiable, and its derivative is the original function small f. So big F is an antiderivative of small f. And we have this useful formula which says that the derivative of the integral of f is the function f itself. Example 1. Let f of x be the constant function 1, defined on some interval a b. The graph of this function is shown below. Let us find an antiderivative of this function. For any point x between a and b, let f of x be the integral from a to x of this constant function 1. This is the area of this rectangle, which is x minus a. So the function big F given by this formula, x minus a, is an antiderivative of this constant function 1. Example 2. Find the derivative of the function, integral from 0 to x e to the t squared dt. By the first part of the fundamental theorem of calculus, the derivative of this function is e to the x squared. Note that it's very difficult to directly compute the derivative of this function because the integral e to the t squared dt cannot be expressed in terms of elementary functions. Example 3. Find the derivative of the function, integral from 0 to x squared, sine of the square root of t dt. By the chain rule in the first part of the fundamental theorem of calculus, the derivative of this function is sin of the square root of x squared times the derivative of x squared. This is equal to sine x times 2x. In general, the derivative of the integral from 0, or from some other constant a, up to some function b of x, of f of t dt, is equal to f of b of x, which is the composition of those two functions, times the derivative of the inside function b of x. If the lower limit of integration is the function of x, let's say some differentiable function a of x, and the upper limit of integration is a constant, for example 0 or some other constant, then we can interchange the limits of integration and add a minus sign. And now we can differentiate this function using the fundamental theorem of calculus. The derivative is minus f of a of x, which is the composition of those two functions, times the derivative of the inside function a of x. In general, if f is a continuous function defined on some open interval I containing the values of some differentiable functions a of x and b of x, then, to find the derivative of the integral from a of x to b of x of f of t dt, evaluate the function f at b of x and multiply the result by the derivative of the inside function b of x, and subtract from this f of a of x multiplied by the derivative of the other inside function a of x.